He knows it doesn't matter what's under a hood. The only thing that matters is who's behind the wheel.
Dumb, it's not quite right. I can tell you why. So here we have three identical boxes with different type of a straight pipe, a pipe with a rounded edge, and a real well-designed air horn, or we can say velocity stack. The bounding conditions are the following. So in these surfaces we have ambient pressure, and down here at the outlet surface of the trumpets or pipes we have a 20% less pressure, so it's like an induction phase in an NA engine, so non-turbocharged engine. Here I prepared, of course, a cross-section where we will see exactly the velocity of the air regarding these three pipes or velocity stacks. As you can see, the more red you got here is the better, because you will have a faster flow throughout these objects. And as you can see, if you have a rounded, then you will get more and more air, and if you have the optimal geometry, then in that case you will have almost a perfect range of the velocity. Like if you can see here also the black arrows, that's the direction of the air, and this volume is more affected, so the whole volume of the box which contains air is more affected if you have a better geometry, as you can see here. Let's see another plot. Here we will see how the air flows exactly into these objects. So let's see a short animation. Here also the red means that's the fastest air particle, like these dots are representing the way of the air. Yes. But what really matters for us is that how much air can we get into the engine, because more air means a little bit more fuel and more power and more torque, of course. So let's just hide this just for a second. And I also prepared mass flow rates. I will show you these. So the first line represents the mass flow rate of this surface, the second line goes to this, and the third is connected to this one basically. The reason why it's minus, because the direction of the mass flow rate points downwards, so that's the reason why it's negative. And as you can see, if you only have a straight pipe on your NA engine for the cylinder, we will have 0.18 kilograms per sec mass flow rate, more than 20% increase if you have at least a rounded edge like this, and if you have the optimal geometry, that means that you will have an additional 10% mass flow rate every second. So that's the reason why you should consider always to have a well-designed air trumpet, because it does matter.
So, after you have your final design of your air horns or intake trumpets, what you need to do is to manufacture them. These trumpets, for example, are 3D printed. 3D printed because the material properties for a trumpet, like an intake trumpet, is enough as you 3D print. What you need to see here, that's an FDM printed part, of course, and because I wanted to have a very good and efficient air sucking in process, that's the reason why I had a 3 phase of sanding, That's the reason why it's so glossy, so the whole surface. And of course from the side you can hear, or sorry, you can see that here this is the line until I sanded it, and then here is not really necessary. But from the side view you can also see that the radius is variable, so it's not a constant radius. And also here I have this small radius to have the best performance of the trumpets. So thank you for watching, and happy air horn designing and happy printing.